AI discovers new moon pits and skylights, revolutionizing lunar exploration. AI on the moon, revealing hidden gateways beneath the surface. Imagine the moon isn't just a barren landscape, but a world riddled with secret entrances waiting to be discovered beneath its surface. That's not just sci-fi, it's rapidly becoming reality, thanks to cutting-edge artificial intelligence, AI. So, what happens when smart technology is set loose on lunar landscapes to search for pits and skylights? The findings might change our entire approach to space exploration. But here's where things get interesting, and perhaps even a little controversial. Recently, a team of international scientists took up the challenge of harnessing machine learning, specifically sophisticated deep learning techniques, to detect surface depressions and openings on the moon, also known as lunar pits and skylights. These features, especially common in regions called lunar maria, act as doorways into ancient lava caves and rock tubes below the surface. Spotting these entrances is crucial, not just for understanding the moon's volcanic history, but for planning future missions, both robotic and human. In their study, researchers trained several deep learning models, using detailed images captured by orbiters circling the moon, and even Mars. Their ultimate aim? To spot new pits and skylights that haven't been catalogued yet, complementing the current list of 16 features found in the Lunar Pit Atlas. A particularly famous landmark, the Mare Tranquillitatis Pit, an enormous opening about 100 meters wide and plunging to a depth of roughly 105 meters, was among the data used to teach the AI how to spot similar features. The research revealed that their ESSA, Entrances to Subsurface Areas deep learning model, was the real standout. Despite only analyzing about 1.92% of the lunar maria, ESSA successfully uncovered 2 entirely new skylights that had been missed until now. Here's the part most people miss. The model has barely scratched the surface, having examined only about 0.23% of the moon's total area so far. That means there could be hundreds or even thousands of undiscovered entrances just waiting for the right AI algorithm. The scientists emphasize that targeting the volcanic mare regions remains a priority, since these areas likely hide more subsurface features. Although, up to now, ESSA has mainly focused on smaller, well-defined deposits within impact craters. With more time and effort, it could be unleashed on much larger expanses, like the mysterious Mare Frigoris, by systematically scanning the moon's surface chunk by chunk. Why does all of this matter? On Earth, our atmosphere and magnetic field protect us from deadly radiation, but the moon is exposed to intense solar and cosmic rays. That's why future astronauts might take shelter in these ancient lava tubes, just like characters did in the National Geographic Mars series, where Martian explorers sought safety inside similar caves. And if you think that's just good television, think again. Scientists are seriously considering this strategy for real-life missions. The timing couldn't be more perfect. With NASA's Artemis project gearing up to return humans to the moon for the first time since Apollo 17 in 1972, these discoveries take on new urgency. Although Artemis is targeting a landing near the lunar South Pole, a region dotted with deep craters and possibly water ice, identifying and understanding all major surface features, including those far from the landing sites, is vital. AI tools like ESSA could one day help us locate not just safe havens, but also invaluable resources like water ice, supporting longer and more sustainable moon missions. And this is the part that might stir up debate. As AI and machine learning techniques race ahead, are humans risking over-reliance on algorithms for space exploration? Or are we on the brink of unlocking the secrets of planetary bodies, both in our own solar system and beyond, at a pace we never imagined? So what do you think? Will AI become the ultimate lunar explorer, or is there more to the story? Could there be unexpected dangers or opportunities hiding in these undiscovered lunar caves? Let's start the conversation. Share your thoughts, doubts, and arguments in the comments below. Keep questioning, keep exploring, and as always, keep your eyes on the stars. AI discovers hidden lunar caves, a game changer for moon exploration. Get ready for a game-changing discovery that could rewrite the rules of lunar exploration. A groundbreaking study published in Icarus reveals how artificial intelligence is uncovering hidden moon tunnels that might just shield future astronauts from the moon's brutal environment. Here's the kicker. These secrets were hiding in plain sight until AI stepped in to analyze decades of lunar imagery. But here's where it gets controversial. Should humans even prioritize colonizing the moon before addressing urgent earthly challenges? Let's dive into how this tech is rewriting space research and why some researchers call it a missed opportunity to rethink our lunar ambitions entirely. What are lunar pits and skylights? Imagine cracks in the moon's surface that lead to vast underground caverns formed eons ago when volcanoes once spewed lava beneath its mantle. These lunar pits and skylights aren't just geological quirks, they're potential life-saving shelters. Think natural bunkers shielding astronauts from radiation storms that would instantly cripple any expedition on the surface. But detecting these features manually would be like searching for needles in a haystack the size of Texas. Traditional methods relied on scientists squinting at images from lunar orbiters for months, with most promising sites escaping notice. That's until AI models like ESSA, entrances to subsurface areas, entered the scene. How AI is overhauling lunar research. The ESSA algorithm has already flagged new skylights in the moon's volcanic plains, right under researchers' noses. This isn't just incremental improvement, it's a paradigm shift. By training deep learning networks on orbital images, the model can scan the moon at scales humans can't and spot patterns invisible to the naked eye. And the potential? Vast. The study notes ESSA has only analyzed about 0.23% of the moon's surface so far, meaning there are likely countless undiscovered pits and skylights waiting to be found. Imagine future missions using these tunnels for in-situ resource utilization, ISRU, like harvesting water ice from permanently shadowed craters. Why this matters for future missions? NASA's Artemis program aims to return humans to the moon by 2025, but current plans focus on the lunar South Pole, where no subsurface caves have been confirmed. ESSA can identify tunnel entrances closer to these landing zones. Astronauts might gain built-in protection from radiation and extreme temperatures. It could be the difference between survivable missions and catastrophes. But wait, could this AI research oversell its promises? Critics argue that while AI speed is revolutionary, it risks missing vital contextual details that human analysts might catch. Others contend that tunnel locations alone solve neither logistical challenges nor ethical questions about lunar resource exploitation. The future of lunar exploration. Looking ahead, ESSA's success could pave the way for 1. Targeted shelter hunts, scanning priority areas near proposed landing sites. 2. Mars, then beyond. Similar AI tools could one day hunt for underground caverns on other planets. 3. Opening a debate. Should lunar colonization prioritize AI-driven resource extraction or preservation of pristine environments? Your turn. Should humanity prioritize settling the moon despite environmental risks, or use AI to first fully understand the moon's resources? Do the benefits of lava tubes outweigh concerns about disrupting pristine lunar landscapes? Share your thoughts in the comments below. This research isn't just about AI. It's a litmus test for whether our space ambitions are guided by short-term thrills or long-term ethical planetary stewardship. Study link: https://www.sciencedirect.com/article PII S0019127.2025 https://www.sciencedirect.com/article PII S0019122.2025.dgcid RSS SD all. NASA discovers hidden cave entrances on the moon. NASA has recently revealed astonishing findings about the moon, uncovering what could be the entrances to its hidden underground world. This week's edition of the Intelligence Brief highlights a remarkable study conducted with the help of NASA's Lunar Reconnaissance Orbiter, LRO, which has confirmed the existence of over a dozen new pit craters on the lunar surface. These craters may serve as natural gateways to subterranean environments, some of which could potentially provide shelter for astronauts in future missions. In this analysis, we will delve into 1. The unique characteristics that set these lunar pits apart from typical surface depressions. 2. The reasons why locations such as Mare Tranquillitatis and Mare Ingenii are particularly noteworthy. 3. The scientific and practical benefits these formations could offer, including protection from radiation for long-term habitation. And 4. The significance of this discovery as a crucial step towards establishing lunar outposts utilizing the moon's geological features. Quote of the week: pits would be useful in a support role for human activity on the lunar surface. Robert Wagner, Arizona State University. Recent news from the debrief. Its meta-optical technology could soon turn science fiction into reality. Here's how. Its recent controversial findings suggest alien megastructures might self-destruct before we ever discover them. Read more. This story was written by President Kardashev Collapse. New study warns alien megastructures could destroy themselves before we ever find them. A scientist from MIT has created an atomic-scale version of the double-slit experiment that challenges nearly a century of debate. Find out more. Einstein was wrong. Idealized double-slit experiment ends nearly 100-year-old debate. New NASA images reveal evidence of a catastrophic flood that occurred 13,000 years ago. It's ahead to topic, finding the details of this transcription. Every step from paragraphs about Argon's red fact transcription contains the perfect cyber job, markdown well, and Katrina patch, including more breaking news at the end of this week's newsletter. Windows into the lunar underground. The moon has always captivated our imagination with its enigmatic surface. From its colossal craters to its vast Maria plains and the elusive far side, the features of the moon, both visible from Earth and those revealed by past crewed missions and current satellite observations, continue to deepen our fascination with this celestial body. Recent data from NASA's Lunar Reconnaissance Orbiter, LRO, has provided high-resolution images that scientists are now using to identify potential access points to hidden underground environments on the moon. The groundbreaking findings, published in the journal Icarus, have revealed more than a dozen new examples of intriguing lunar features known as pit craters. These craters may not only serve as natural entryways to subsurface lunar environments, but could also provide future astronauts with shelter while safeguarding scientific treasures from the moon's harsh surface conditions. Into the pit. Pit craters are steep-walled, predominantly circular depressions, formed when surface areas collapse into a void beneath, often due to the presence of lava tubes or caves. Unlike simple depressions or collapse pits that uniformly collect light, true pit craters with subsurface access display distinctive shadows that change over time. These shadows, captured in images from the LRO's narrow-angle camera, indicate the presence of significant overhangs or openings beneath the surface. A recent study has analyzed nearly 15 years of imaging data from the LRO, employing advanced image processing and shape-from-shading techniques. This research has led to the identification of over 100 pit craters, with 16 of them being strong candidates for entrances to deeper subsurface lunar voids, natural entrances to the moon's underworld. The researchers noted, what we're seeing are natural entrances, some with floors deep in shadow, even at high sun angles. Interestingly, many of the most promising candidates are located in well-known areas, including Mare Tranquillitatis, the site of the first lunar landing, and Mare Ingenii. These locations are not only well studied but also feature ancient volcanic plains that are conducive to the formation and preservation of lava tubes, which the newly identified pit caves could potentially access. Beyond shelter, a science and safety opportunity. While the prospect of exploring the lunar underworld is undeniably exciting, there are practical reasons for scientists to investigate pit caves. Their primary value lies in their potential to support long-duration missions. Intact subsurface lava tubes could provide essential shielding for astronauts and sensitive scientific instruments against radiation and other extreme environmental conditions encountered during lunar missions. Additionally, these cave environments would protect against micrometeorite impacts, which frequently occur on the Moon due to its thin atmosphere. Inside these lava tube caves, astronauts would not only be shielded from external threats, but would also experience more stable temperatures and an environment where untouched lunar material may exist, offering a pristine record of the Moon's geological history. The study emphasizes these environments could prove critical not only for scientific study, but as infrastructure for human habitation. Next steps toward exploration. The study suggests that the most promising pits identified should be prioritized for future missions as potential landing or robotic exploration sites. These pits, characterized by consistent internal shadowing and favorable terrain, could be the focus of targeted scouting using future lunar orbiters and landers, which may confirm whether these entrances lead to more extensive underground networks. This new study provides the most comprehensive analysis of these enigmatic features to date, significantly enhancing our understanding of lunar pit caves and marking a vital first step toward transforming natural lunar features into functional outposts for future exploration. This concludes this week's edition of the Intelligence Brief. You can read past editions of our newsletter on our website, and if you found this installment online, don't forget to subscribe for future email editions. If you have any tips or information to share, feel free to reach out via email or on social media.